Chapter 7, here's your individual test. All right, the hardest part I think you guys had on this one was being able to pull that B value out. The B value is the coefficient, the number in front of the T right here. So this is G of T or Y, 2 cosine. The B value is 1/2. You have to pull 1/2 out of this pi over 3. So you're going to divide pi over 3 divided by 1/2. We don't divide, do we? When we have fractions, what do?
Flip and multiply.
We flip and multiply. So you're going to take pi over 3 and you're going to actually multiply it by 2 over 1, which, what do you get here when you multiply that?
2 pi over 3.
2 pi over 3, and then plus 3. So did everybody see how I did that? You're going to take your B value and you're doing pi over 3 divided by that 1/2. So you may have to divide, flip and multiply. So what does that tell us? We're going to go in order. This is a vertical stretch by 2. What does that do? That's going to be a horizontal compression, stretch, because it's 1/2. You flip it, flip that 1/2, and it's going to be a 2. Horizontal stretch by 2. And then 2 pi over 3 to the left. Why left? Because it's the opposite of this number. And 3 up. Question. Next one, number 2. We are talking about writing a sine function. And we know that the interval, a period, is 2 pi over b. That's the definition. So they're telling you that this equation is compressed vertically by a factor of 1/2. So what we have, if it's compressed vertically, the 1/2 goes in front. Now it says that the period, the length of one full cycle is pi over 3. So what we have to do, because it's a sine curve, we're going to set 2 pi over b, because that's the definition of the sine curve, and we're going to set that equal to pi over 3. We have to cross multiply. We get 2 pi times 3, which is 6 pi. The pi's cancel, so what's our b value? 6. That's the number that goes in front of the parenthesis. That's how you find the b value. Now, if this word were tangent, what's the definition of a period for tangent or cotangent? It's pi over b, not the 2. And then you would do it that way if it's a tangent. Now this is saying that we have a phase shift of pi over 6 to the left. So if it's to the left, what do I do?
You add it.
You add pi over 6. If it's said to the right, it would be minus. Now this doesn't say up or down, so you don't have to have anything adding after the parenthesis. Do you get this?
You have to have a negative on that. It's reflected over the
Oh,
axis.
did I forget something?
Yeah.
Oh, thank you, Chelsea.
So if it's tangent, it's going to be pi over
Yes.
b. Okay.
If this said tangent, it would be pi over b equals to pi over 3, and then you would cross multiply.
Okay.
Okay, and yes, Chelsea, I forgot this little piece right here. It says reflected over the x-axis, remember? That's a negative right there. All right. Do you remember what the tangent graph looks like? The tangent graph, we have asymptotes at pi over 2 and negative pi over 2. And it looks like this, right? What an odd function means is that it has symmetry to the origin. If you were to pick a point here and draw it through the origin, it would be symmetrical. Also, what's the other way to know if something's odd? If this point is, let's say, pi over 4, and this would be 1, then guess what this point is right here? Negative pi over 4 and negative 1. Remember odd? An odd function, you change both of the signs of your x and y. Now, what other trig function was odd? Was the sine curve, because it was on, above, on, below, on. So you look, here's your sine graph. See this point right here? This was pi over 2, 1. This is pi over 2, 1. And guess what this point was right here? It was negative pi over 2, negative 1. That's what an odd function means. So you can just remember it. Tangent and sine are both odd, and even is the cosine graph. Why is the cosine graph even? Anyone remember why? It has symmetry to the y-axis. Next one, number 4. How do you find the y-intercept of this graph? Well, you could easily, the easiest thing to do is to sketch the graph of it. So this has a new x-axis at negative 4, 1, 2, 3, 4. Here's your new x-axis. And the cosine graph for this one is going to start, the amplitude is 3, so it's going to start 3 above, and then it goes like this. So where is this thing hitting the y-axis? At 0, negative 1. That's your y-intercept. Number 5. The domain the domain for all sine and cosine curves is what? Yeah, this thing's, they go on and on and on. That's your domain, all real numbers. But the range, there's a limit to the y value. It only goes so high and so low. So there's two things you could do. You could, to find the range, you could graph this. So this is 3 above, this is your new x-axis, and you could go, this one is a negative 2 amplitude, so it's here, and then here. So that's basically all you really need. So you need to figure out what these two numbers are here, which are what? What's that and what's that? What is that number? 1, and what's this? 5. So your range is actually 1, 5. And you want to put these numbers in order from least to greatest. Now there was a shortcut we showed you how to do the range for this one. Does anyone remember what it is?
Plug in 1 and negative 1.
Mm-hmm. So right here you could plug in a 1 and do a negative 1. And you will get 1 and you will get 5. Now what if it were the tangent graph? The tangent graph, which I have right here, tangent graph is your domain all real numbers. No, you can't have x values here. We have asymptotes. Same with cotangent. Cotangent, we don't, it's not all real numbers for domain. But our range is all real numbers. That thing's shooting up. Shooting down. So your range on your tangent and cotangent is all real numbers. But your domain, depending on which one it is, you have to say it's all real numbers except pi over 2 multiples or every pi, depending on which one it is. Read your notes. Okay, backside. Number 6. I am going to show you my beautiful graph. Actually, I'll draw it. Draw it again. How do you graph this sine curve? Well, the directions say I want from negative 2 pi to 2 pi. Well, let's do our increments. Pi over 2, pi, 3 pi over 2, and 2 pi. How do you graph this curve? Let's see how much you remember. Does it start on? On, okay, and then where am I gonna go? Do I go above?
Below.
No, where do I go?
Below.
Below, on,
Above.
above, and on. Okay, now, am I done?
No.
Why?
Because it's the other side.
Because the directions say from, I want to go from 2 pi, what's missing? This way. So I have to do negative pi over 2, negative pi. So all I have to do is continue this pattern. All right, whoops, kind of went a little crazy there. Okay, so now they're asking for, I want the interval where this graph is increasing. Remember, we read a graph left to right. If you were on this roller coaster, you're on the Gemini, okay, and here you are, you started the ride right here. What are you doing? Are you increasing?
No.
What are you doing?
Decreasing.
Right here you're increasing. Where else are you increasing? You're going down and you're increasing there. So can you describe that those intervals? And from left to right. So what's this? So it would be from negative 3 pi over 2 to what? Negative pi over 2. Now why am I not using brackets?
Because it doesn't continue. It just
Because
is
right
linear
here,
line.
that's when you're at the top of the roller coaster, and we're just, let's say, we're just sitting there, straight, for that second. Okay? All right, next. This section is very important. Everybody watch this segment here. We are going to draw the unit circle, and I'm going to put in all the angles. Everyone should be able to do this on their own. If we took the circle and started with 0 and counted, let's name all our major landmarks. Pi over 2, pi, 3 pi over 2, and what's this? 2 pi. Okay, so let's break up the angles now. Let's cut this in fourths. This is 1/4, 1/4. This is 2/4. What's this? 3/4. What's this? 4/4. What's this? 5/4. And this is 6/4. And this is 7/4. And this is 8/4. Now, I want to say something really quick. See, this x-axis is very important. Everything is measured, these angles are measured off the x-axis. So when we're talking about a 45-degree angle that's in quadrant 2, it's this angle. If I'm talking about a 45-degree angle in quadrant 3, it's 5 pi over 4. If I'm talking about a 45-degree angle in quadrant 4, it's 7 pi over 4. What do you notice about all the 45-degree angles? What do they have in common, everybody? A 4, where? In the bottom, good job. Okay, now let's do the 30s. A 30-degree angle is otherwise known as pi over 6. So if we were to break from here to here up into 6s, This is 1/6. This is 2/6. This is 3/6. What's this? 4/6. This is 5/6. 6/6. 7/6. This is 8/6. This is 9/6. This is 10/6. And this is 11/6. And 12/6 is 2. Okay, now look at these 30s. These are the 30s off of the x-axis. These are the 30s off of the x-axis. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So if I'm talking about a 30-degree angle that is attached to the x-axis, if it's in quadrant 2, it's 5 pi over 6. If it's in quadrant 3, it's 7 pi over 6, and if it's in quadrant 4, it's 11 pi over 6. Now, there's these angles right here that are not reduced. If you were to reduce those angles, what would they be? They would be thirds. All of them are thirds. So this is 1/3, which is 60 degrees off the x-axis. This is 2/3. This is what? 4/3 off the x-axis. And this is 5/3. So all of the 60-degree angles that are measured off the x-axis have 3's at the bottom of them once they're reduced. You got that? Okay, so now we have to know the x and y axis by heart. In quadrant 1, all of your x values and y values, do you agree, are all positive?
Yeah.
In quadrant 2, when we go to the left, that means our x values are negative, right? And our y values are positive, right? In quadrant 3, all of our x values are negative, but so are our y's. And in quadrant 4, our x's are positive and our y's are negative, right? Well, by definition, the sign value is y over r. Y over r. So that means, and r is always positive. So in what quadrants is the sign value, are the y values positive? Here and here. So sine is going to be positive in this quadrant, and it's going to be positive in this. So sine is positive here, and sine is positive here. Are you guys okay? Okay, cosine. Cosine is x over r. Well, in what quadrants is the x value positive? R is always positive. 1 and 4. So cosine is going to be positive here, and it's going to be positive here because x is positive. And tangent is y over x. So we want both of these to be, the only way to get a positive number if both numbers are positive or if both numbers are negative. So tangent is going to be positive here and here. So what does this mean? All of the trig ratios are positive in quadrant 1. Only sine is positive in quadrant 2. Only tangent's positive in quadrant 3, and only cosine's positive in quadrant 4. Which means what? Which means what? I talked about the positive ones. The other ones are negative. That means for every angle, for every cosine and sine, you have 2 positive, 2 negative. So sine is positive in these two, but then it's negative in these two. Cosine is positive in these two, it's negative in these two. And tangent is positive in these two, that means it's negative in these two. Does that make sense? Okay, so now, the grand finale. Your job for this next section is to look at your triangles very carefully. So if you have a 30, 60, 90 degree triangle, you better know by heart these angles and these ratios by heart. And the conversion from radians to degrees and vice versa. Okay? So all of these things are thrown at you simultaneously. So if I say, hey, what angle am I whose ratio is a √3/2, but it's negative? So this is telling me a couple things. I want to know what two quadrants am I talking about. I want the negative two quadrants for sine. So we go back to this. What two quadrants is sine negative in?
2 and 3.
In negative? Negative?
3 and 4.
3 and 4. Sine is negative in 3 and 4. Sine is positive in 2.
Oh, wait, which one are we on?
This, I just made this up.
Oh, sorry.
I made this up.
Okay.
I made this up.
I thought we were on the number 7.
So sine is negative in quadrant 3 and 4. So you have to pretend, okay, what if, I'm going to ignore this negative. What angle measure is the side opposite over the hypotenuse √3/2? What angle am I? You're playing Kahoot. What angle is this? Quick.
1.
That's
completely wrong.
60. How do you write 60 in radians? Good. 5/3. So now, one. I want to know, I want those two 60-degree angles in these two quadrants. I want the two 60-degree angles in these two quadrants. So go back to this. What are the two 60-degree angles?
4/3 and 5/3.
You got it. What if I didn't have a negative there?
Then be
You
the
use
ones
the top
above.
stuff.
It would be the 2 pi/3 and the pi/3. Get it?
Mhm.
Okay, so the one that was asked on your test, when you see √2/2, that's a 45-degree angle. That you should recognize as a 45. So your angle in question is a 45er, but in what two quadrants is cosine negative in? In what? In 2 and 3. So you're in this quadrant and you're in this quadrant. So what are those two angle measures in quadrant 2 and 3 that have a 4 in them? And then add and subtract your 2k pi. Do you get this, guys? Okay. Now, for the ones that are sine and cosine that have a 0, 1, or a -1, you're in these 4 special places here. 0, these are the angle measures that you're at. Now, how do you know where you're at? Well, this ordered pair is 1, 0, this is 0, 1, this is -1, 0, and this is 0, -1. By definition, sine is y/r. So how are you going to get a 0/1 ratio? Where is the y value 0? Where is the y value 0?
Pi and 0.
Pi and 0. These two places, your y value is 0. What if I would have had a 1 right here? Where is the y value 1?
Same.
Where is the y value a 1? So it'd be pi/2. What if I had a -1 here? Where is the y value -1?
3/2.
Now what if I change this word to cosine? Then what am I looking for? Where the x value is either 0 or 1 or -1. Do you get this? Okay, next one. This one is √3/1. So what angle am I whose side opposite over adjacent is a √3/1? What angle am I? It's a 60, so pi over 3. So in what two quadrants is tangent negative in? In what two quadrants is tangent negative in?
2 and 4.
So what's the angle that has a 3 at the bottom?
Rachel, mom's calling
What is it? Yep, 2 pi over 3 and 5 pi over 3. Does everyone get that? So you're using this ratio to come up with your angle, which is pi over 3, but then you're going to refer to the quadrants that the tangent is going to be negative in, and find the angles that have that 3 at the bottom, which is in quadrant 2, it's 2 pi over 3, and in quadrant 4, it's 5 pi over 3. Now, had this negative not been there, the two answers would be pi over 3 and 4 pi over 3, if it was a positive. Questions?
They would have plus minus 2k pi on it.
And yes, definitely add your plus or minus 2k pi on all these.
Now when is it plus minus like k pi?
K pi, just for now, just write 2k pi. We're gonna get into that. We're gonna get into that more. The reason why we do k pi for tangent is because it happens faster every 180 degrees or every pi radians. So you don't have to write both of them, but for now, just be safe and just write plus or minus, write both answers and write plus or minus 2k pi. We'll get more into the other stuff, yeah.
How do you rate the answer for number 8?
Number 8, you're gonna write, your two answers were, we said,
Number 8, next to it.
2
No, the one next to
pi.
it.
Oh, number 8, I'm sorry.
You can still do that one.
Yeah, let's finish this one. 2 pi over 3, and what else did we say? We said
5
5 pi over 3. And then just write plus or minus 2k pi. See, technically, you could just write this answer and write k pi. Because if you were to add pi to this answer, you'll get your 5 pi over 3. If you were to add pi to this answer, you get 5 pi over 3. But I want you to do it, write them both out. Now this one, we said, where is the y value 0? And it's here and here. So it's 0 plus or minus 2k pi, and pi plus or minus 2k pi. This is another one that can be shortened to 0 plus k pi, plus or minus k pi. But just write it out that way. Questions, anyone? Next, how are you guys with writing these graphs? This one is, there's no phase shifts on these two. This is going to be your cosine graph. You should know, if it starts above, it's a cosine. If it started on, it would be a sine. So it's a positive 3, the amplitude is 3, cosine, and then minus 3. Questions? Number 11 is the tangent, or actually this one's the tangent graph, but it's backwards. It's so it has a negative in front of the coefficient, and in the steepness is 2. So it's negative 2 tangent, and it's a shift, what? How high? Up to.
Wait, like, why is that negative?
Because the tangent graph is normally goes this way. Now the reason I know it's tangent is because where your asymptotes are. Your asymptotes are at pi over 2, negative pi over 2. If the asymptotes were at 0,
Well, I get why it's tangent, I just don't know why it's like.
it's negative because it's flipped. Normally the tangent graph looks like this. it normally goes this way. See, it looks, think of a positive slope line. It's normally shooting upwards. Like if you were to stretch it out, it looks like a positive slope line right here. But because it's going backwards, that's where it's flipped. That's why. That's the only reason why. Okay. Next. Absolute value. I've got a way that okay. Did anyone struggle with these ones?
Yeah.
Yes.
You did? This is how I remember the difference between the absolute value ones for sine and cosine. The cosine one, it breaks, I don't know how you want to call that, but they look like mountains like that. This is how I remember it. The absolute value cosine one breaks this, what do you want to call it, a mountain? It'll split it in half. Versus the absolute value of the sine one will look like this. So how do you want to remember that? Does that make sense? Do you see the difference? You got it? Because the cosine graph starts high. It starts high. Rachel, are we on?
Yeah, I just gotta back it up a little bit.
Do I need to move down or up?
We're good.
No, it's good. It's good.
Okay, so this one, if you break this in the middle, that's the cosine one. This one is the sine one. The sine one is in between, because the sine graph starts on, it goes above. So for number 12, the reason why the amplitude is 4 is because of the 4 there. And why is it upside down? Because it's flipped. If this negative weren't there, they would be going, it would be the way I have it drawn on the paper.
Thanks.
Questions on that? Here's number 13. 13, you have your new x-axis is at -1, do dot, 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 dot at -1. And it starts below, or it starts on, but it's a -3 amplitude. So it's gonna go on, below, on, above, on. And she wants from -2 pi to 2 pi, so that's what you should have graphed. Remember, your amplitude is how high off the x-axis you are. Questions? Here's 14. 14, you are going to graph not the secant, well, you're going to graph the cosine. So you're going to go 3 below, dot, 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 dot. And the cosine graph starts above, so it's 2 above, and I have to draw my curve. I have to draw it in. I draw it in, and then where it hits the x-axis, those are your asymptotes, and then you draw your little parabolas. Questions on that? Number 15. This one is 3 above, and it's the cotangent graph. Now the cotangent graph looks like a negative slope line if the coefficient's positive. So it's 2, it's going to go 2 above, the steepness is 2, but remember, your new x-axis is at 3 above, and your asymptotes are now not at pi over 2, but at 0, pi, 2 pi, -pi, and -2 pi. So be careful with your asymptotes. For tangent, you gotta memorize. Tangent asymptotes are at pi over 2, and for cotangent, it's at 0 and pi. Questions? How are we doing for time?
We have like 10 minutes left.
Oh, good. Okay, next one, number 16. I'm gonna do this one by hand. For you. Okay, number 16. So we have an amplitude of what?
3.
Okay, how do you find your period? What do you do?
Block the 3.
2 pi over, what's the b value? 3.
So you always do 2 pi over b value?
That's your b value, yep. Now you may wanna, at this point, do what?
Pull off the 3.
Pull that sucker out. Pull it out. How are you gonna pull? How are you gonna divide? How are you gonna divide pi over 4? How are you gonna divide that by 3?
Flip and multiply.
I'm gonna multiply by 1/3. So what is your phase shift? What is this?
Pi over 12.
Yep. And then minus 2. So we have our phase shift is pi over 12 to the left. It's always the opposite of that. Now our increments, you always take your period and you're gonna cut it into 4 parts. Why? Because there's 4 increments in a period for sine and cosine. Now I could simplify this, but I'm just kind of looking ahead and saying, oh, I have to get these 2 in 12ths anyway. So I'm gonna leave it as 2 pi over 12. Does everyone see that? Okay. We're starting at pi over 12 to the left. Negative, that means negative pi over 12, by the way. And by the way, our vertical shift is 2 down. So now, let's put it all together. We're starting 2 down. Here's our new x-axis. We're not using that x-axis, we're using this one. We're starting here at negative pi over 12, but we have to count by what?
2 pi over 12.
2 pi over 12. So can you add 2 pi over 12 to this? What do you get? Pi over 12. Now add 2 pi over 12 to that.
3 pi over 12.
Add 2 pi over 12 to that.
5 pi over 12.
Add 2 pi.
7 pi over 12.
And let's stop for a second. She wants 1 full period. So that's good. You have to have five numbers down. So where do we start? The sine graph starts on, because it's a positive, and we're going to go 3 above, on, and there it is. Done. We need to see these numbers here. Don't reduce them. Questions?
So whenever it's like if it was pi over 12, then you would just go from negative pi
Uh-huh.
to 0 to pi. So since, like if that was 3 pi over 12, you would go up 3.
Wait, say it again?
If
what
that
was?
was 3 pi over 12,
If
for
what?
increment,
Oh, then you would add 3 pi over 12, and then you'd have, if this was negative pi over 12, and if you were to add, you'd have 2 pi over 12. Yeah. Questions, anybody? Okay, moving along, number 17. Tell me what to do. This is a cotangent. Now the difference between tangent and cotangent is we have to find our first asymptote. Where is our first asymptote on a regular cotangent graph? Where's our first asymptote? Where? 0. So you're going to set this mess, this 3t minus pi over 3 equal to 0. Because that's where our first asymptote is for cotangent. What if it said tangent? What would you set that equal to then? Pi over 2, because that's where the first asymptote is for tangent. So you're going to do this, and we're going to find where our first asymptote is. So if you were to add, you want to find out what t is. So solve for t. So 3t equals pi over 3. And you're going to multiply by 1/3. You're going to get t is pi over 9. That's your first asymptote. That's like your phase shift. That's your start position. You're gonna start here. Start at pi over 9. Okay, so let's fill in this. Our steepness is 2. Our period, instead of 2 pi, what is it?
Pi.
Pi over 3. We cut our increments into parts. Why?
Because that's what it is.
Because that's what it is, pi over 6. So what's wrong with these two now?
They're different.
They're not, how can we count by 6s when we're gonna start at a 9? So what's our common denominator? I'm gonna do 18. So this is 2, we're gonna start, instead of saying at pi over 9, we're gonna start at 2 pi over 18. And this is gonna be 3 pi over 18. We're gonna count by 3 pi's over 18s. And our vertical shift is, we're not going anywhere. We're staying on the x-axis. So, where are we starting?
2 pi over 18.
We're gonna start at 2 pi over 18, and we're gonna count by, that's our first asymptote. And we're gonna count by 3 pi, so what's our next?
5 pi over 18.
5 pi, this would be 5 pi over 18, then what?
8 pi over 18.
8 pi over 18, and at 8 pi over 18, what are you gonna have? A broken line. Dot, 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 dot. Then what?
11 pi over 18.
11 pi. And then what?
14 pi over 18.
And then,
17 pi over 18.
yep. Now, there's our asymptotes. What does our cotangent graph look like? We gotta put our dots in. We only want 2 periods. Cotangent looks like a negative slope line. We're gonna go 2 up. Like that. And we are done with that. Questions? Okay, number 18 I'm gonna put up here because we're running out of time. You're gonna graph the cosine curve, same as the way we did it. You have to figure out what your phase shifts are and you're moving it down. This is a amplitude of 1. Your period is 2 pi over b, which is 2, so it's pi. Your increments are pi over 4, cut that into 4 parts. It's a phase shift of pi to the right and then down 1 and draw your graph. We're looking at, we need these numbers right here. And then the last one, a lot of you guys had trouble with this. How do you write the 2 equations of A and B? Well, I need to know what B is, not this B, but I need to know what the B value is. So I'm going to start here. I'm going to put this on, this last question will be on YouTube, it'll be on a separate video. So look for the 2 if you want information on this one.